Okay, let's go ahead and get started. I am James Fowler. I am the Graduate Program Director here in the Department of Electrical and Computer Engineering. So I'd like to welcome you all to graduate school in the ECE and at Mississippi State. So if you haven't already gone ahead and signed in at the back, please go ahead and do so.
What's that? When do I need?
The after lunch around noon, 12:30, something like that.
See you then.
All right. Please sign in at the back if you haven't done so already, and pick up a copy of the graduate handbook back there as well. So what I'm going to do today, we're going to start off by going through a number of the policies and procedures that you need to know about at the graduate school here at MSU, and particularly in the ECE department. And then we'll be having some lunch. We have pizza coming in around 11:30. After pizza, we'll be getting started again with some presentations from the various emphasis areas, as well as Mr. Ellis will be talking to you about computer access. We have a couple other people as well. Then we should be wrapping up down here about 1:30, heading upstairs to the second floor. And I'll meet with each of you in my office, and we'll get you released for registration, and then you'll be able to sign up for classes later this afternoon on your own. So as I go forward here, if you have any questions, please do not hesitate to ask me. We have a lot of material to cover, and so if you have a question, let's get to it right then and there rather than waiting. Okay, so starting off, this is the graduate section of our website. So there's a lot of information on here that you find useful, particularly down here at the bottom. Scroll. There's me, my contact information. I do list the phone number, but I rarely answer the phone. Sending me an email is generally the best way to contact me. Although you are welcome to stop by my office in room 225. That's inside the main office of the ECE department. If I'm there, I can meet with you. If I'm not, and I'm often not because I do a lot of traveling, send me an email. My assistant, Ms. Cheney, is also available to help you. She's the first person you see when you walk in the door of the main ECE office, and her email is right there. She, in particular, will be your primary point of contact for getting registration released for subsequent semesters. We have some students who have agreed to help us out. John Rogers is our domestic graduate ambassador. John Hutton is our domestic but distance graduate ambassador for distance students. And I have yet to find an international graduate ambassador, but I will do so shortly. And when I do, I'll update the webpage, and I'll also update the graduate handbook. So these are students that you can contact and ask them questions. A lot of times you'll have questions that really need to be answered from the perspective of a student. And I have never been a student here at MSU, so there's many things that I don't know about student life. These people, though, do, so they can help you, and so don't hesitate to contact them. Okay, so other information on our website. We'll be working through some of this, but the most important thing is the graduate handbook. I update the graduate handbook every summer, right before the start of the fall semester, and we see a link here for the most recent version, and you have that in your hand. All the past versions are here as well. And so let's go over to the graduate handbook right here. Okay, so this is a new screen. It's the first time I'm using it, so please bear with me as we have problems scrolling and such. Okay, get this good to the next page. I just need to get these down here. Okay, so starting off here, you'll see that some of the same information that was on the website. And then a special note, the university also has a very extensive document. It's all online. A lot of policies and procedures from the university level are there. We won't be going over those. Most of everything that you need to know is contained in this document. But if you go to this link, you can see all of the university policies and procedures there. Of course, the university policies and procedures are the final law, so we have to abide by all of those. And nothing in the policies and procedures that we have in this document is intended to contradict anything in the university guidelines. Okay, so in the handbook, we have some general information and policies, and we'll go through all of those as you need to know that information. And then we have policies and procedures that are specific to the master's program as well as in the PhD program. And we'll walk through first master's and then PhD. But the stuff that we start off with is applicable to everybody. Okay, so some general information and policies. Okay, so things in graduate school operate a little bit differently than what you're used to perhaps in your undergraduate career. Grades that are below a B on graduate level coursework are considered not to be good. So anything lower than a B will result in the very least a letter of warning coming from me. And if you get more than one letter of grade below a B, then you can run into problems. So we're starting with the A's: academic performance, academic probation, academic dismissal. And we're going alphabetically through these topics. I don't expect that any of you are going to need to know about academic probation or academic dismissal. Indeed, I hope that you don't ever have to encounter these subjects before or after now. But we're just working through this alphabetically, so we'll be talking about them right now. So if you get grades below a B, then your GPA may fall below a 3.0. And if that happens to you, you will be placed on a status called academic probation. While you're on academic probation, you will not be eligible to receive any type of financial support. This includes teaching assistantships, research assistantships, wages, and fellowships. And the reason that we do this is that we want you to be focused on your grades. You don't need to be doing research, you don't need to be doing any teaching, you need to be focused on getting your grades up. Because the university will not let you graduate with a graduate degree if your GPA is below a 3.0. You don't take a whole lot of classes as a graduate student, so if your GPA ever dips below a 3.0, you're going to be in peril of not being able to graduate. You need to take corrective action immediately. And so that academic probation is a way for us to make sure that you know what you need to do in order to get graduated. So if you're an on-campus student, to be removed from academic probation, by the end of the next semester, and the summer is counted as one semester, you need to raise your cumulative GPA back over a 3.0. If you're a distance student or other part-time student, then over the next 9 hours that you take, you'll have to raise your GPA above a 3.0. Now, hopefully if you do go into academic probation, that'll happen one time and then that'll be it. You won't have any other problems. If that's not the case, though, you can face academic dismissal. So the following are ways that you can get yourself dismissed from the program. If you are on academic probation at one point in the past and then your GPA again drops below a 3.0, then you will not go on to academic probation again. Rather, you will be dismissed from the program. So you can only be on academic probation for one semester. Any grade below a B is bad. Any grade below a C is going to result in you being dismissed from the program. So if you get a D or an F on a graduate course, you will automatically be dismissed from the program. grades at C are not good, but you can survive one of those. You can in fact survive 2 C's, but on your 3rd C, you will be dismissed from the program. Indeed, you're going to have a hard time having a GPA over 3.0 if you've had 3 C's, and so you're probably not going to be able to graduate anyway. A grade of U. Now, our research hours are graded S for satisfactory, U for unsatisfactory. There's not a letter grade associated with the research hours. But if you get a U, which is unsatisfactory, in 2 consecutive semesters, then you'll be dismissed. And then finally, there are a number of examinations. Master's students and doctoral students both have a number of examinations. We'll talk about those in detail when we get to the master's and PhD specifics. But effectively, you have the opportunity to take the exams twice, and if you fail the 2nd time, then you'll be dismissed from the program. But we'll talk about that as we get further down. Okay, so it is possible to appeal your dismissal if you have been dismissed, and you have to do that within 4 weeks of being notified of the official dismissal. And so you see the process here. If you appeal first to the department. If you're unsuccessful, you have the option to appeal to the college. If you're unsuccessful there, you can appeal to the provost. Okay, again, we're going through the A's. I hope that you don't have to know anything about academic probation or academic dismissal from this point on, but if you do, this is where you find all the information that you need. Okay, application for admission, well, you've already done that. Building access. We'll be talking with Mr. Ellis in a little bit about how to get into the building, so we'll skip that for right now. Course load. This is something that's going to affect you pretty soon because you'll be signing up for classes this afternoon. So you'll need to know a little bit about what's expected of you in terms of the course load. So from the university standpoint, to be classified as a full-time student, you have to be enrolled in 9 or more credit hours during the regular semester. This is a spring or a fall semester. And so this is important for international students because legally, to maintain your visa, you have to be a full-time student. Full-time, according to the university, is 9 credit hours. However, in our department, the normal graduate course load is considered to be 13 credit hours. Greater than 13 credit hours is considered to be overload, and you have to be given special permission to sign up for more than 13 hours. And the maximum load in the spring or fall is 16 credit hours. The university won't let you get any higher than that. And in the 5-week summer term, the maximum is 7 credit hours. Now, like I said, the graduate course load, normal graduate course load in ECE is considered to be 13 credit hours. So in most cases, that should be the target that you're trying to get to in terms of credit hours each semester. If you are a teaching assistant or a research assistant, or if you have a fellowship, then you are required to enroll in 13 credit hours in the spring and the fall, and a minimum of 6 credit hours in the summer, except when you take an ESL course. And I'll talk about ESL in just a moment. So almost all the time you'll be taking 13 credit hours if you're on a TA or an RA position, except when you take an ESL course. Okay, international students must be enrolled in 9 credit hours to be considered full-time under immigration law, and you can't drop below 9 credit hours without prior approval from your major professor and also from the International Services Office. Now, occasionally an international student will take less than 9 hours. This is typically in the last semester, like before they graduate. They only have to take 1 class or something like that. But that's rare. Okay, ESL. What is ESL? ESL is English as a second language. Whenever you have an ESL course on your schedule, the university treats your schedule differently. The university puts a limit of 9 hours on your schedule if you have an ESL course on your schedule. If you enroll in more than 9 hours, then the university is going to charge you extra tuition. And that extra tuition will not be covered by a research assistantship or a teaching assistantship. So, it's very important that when you have an ESL course on your schedule, that you register only for 9 hours and do not exceed that. The university will not stop you from registering for more than 9 hours, but if you do register for more than 9 hours and you have ESL on your schedule, you will get a very large bill for tuition. It will be several thousands of dollars. You do not want that. You do not want to pay that. We can get that taken care of, but it's a very large amount of work. It involves a lot of administrative offices to get that fixed. So remember, 13 hours unless you have ESL on your schedule, then it's 9 hours maximum, okay? We'll talk a little bit more about ESL in just a moment. Okay, course retakes. The university does permit course retakes, but the department does not. So course retakes are not feasible in ECE. Cross-listed courses. Occasionally you'll find a course that you want to take that'll be the same course that's being offered in the computer science department, for example. There'll be a course listed as a CSE course in the catalog, there'll be an ECE course listed in the catalog, but they'll be the same class, they'll be in the same room with the same instructor. As an ECE student, if you take a cross-listed course, you must take the ECE section of the course. You can't enroll in the other sections of the course. Okay, curricular practical training, that comes much later in international students' lives, so we'll skip over that. Directed individual study. We do offer the possibility of doing directed individual study with a professor. This is typically a research project that you work on with the professor one-on-one, and you do it for course credit. And in order to be able to participate in directed individual study, you have to submit a proposal, and the deadlines for the proposals are as follows. For the upcoming spring semester, for example, the proposal is due November 15th. For fall semester, this current fall semester, the proposal is due July 15th. So it is too late to do a directed individual study. In particular, you can't do a directed individual study in your first semester of enrollment. You can only do one directed individual study in a semester, and only 2 directed individual studies may be counted towards your program of study. That is counted towards your degree. So there's a maximum that we permit. The faculty in the department may be the instructor for only 2 directed individual study sections in a semester. So if you want to do a directed individual study, you want to talk to your professor very soon before that professor has committed to doing directed individual studies with other students, because that professor can only do 2 maximum. The research cannot be part of a controlled project as defined by ITAR. That's not something you need to worry about, but your professor needs to worry about. And then you can do a directed individual study in another department. We do have occasionally students take a directed individual study in the computer science department, for example. When you do that, you follow the rules in the computer science department for directed individual study, not the rules in the ECE department. So if you want to do a directed individual study with a professor in computer science, that has to be done as a CSE 7000, and you have to talk to the computer science department as to how to go about doing that. I have no control over that, and I have no knowledge of their processes over computer science or any other department as well. Okay, assistantships. So we have several forms of assistantships in the department, teaching assistantships and research assistantships. Some of you have a TA already, some of you have an RA. To have a teaching assistantship, if you don't already have one, you have to pass what we call the TA workshops, or the TA certification process that is offered by the Office of the Graduate School at the start of both the fall and the spring semesters. So we need certification at the TA2 level. You cannot hold a TA position until you have been certified at that level. So if you don't already have a TA position, but you think you might want to have one in the future, then I would encourage you to get registered for the TA workshops in January so that you will have that certification and can then serve as a TA. Okay, another important thing is if you are an international student and you are in the first semester as a teaching assistantship, then you need to enroll in ESL 5323. So every international student has to take ESL 5323 during their first semester of enrollment. So here we are back at ESL. So if you are a TA this semester, and how many, raise your hand if you have a TA position for this semester, and you are an international student, then you will be signing up for ESL 5323. How many hours should you have on your schedule? 9. Very good. Okay, research assistantships. Well, if you have an RA position, this is something that is given to you by a faculty member. The faculty members control the research assistantships, and the way these work is that a faculty member has an idea for some research. They write a proposal to a funding organization like the National Science Foundation or the Department of Defense, NASA, etc. And if they get lucky, they get awarded the money. They will then hire students to conduct that research work. Typically, they're only going to be interested in hiring students that are in the area of the research work. So if you are a power student, do not expect that the faculty in the signal processing area will be interested in hiring you as an RA, because they really need people with signal processing skills and research experience. Likewise, if you're a signal processing student, don't go to the power faculty expecting to get any funding out of them. A lot of times, professors would like to see students in the classroom for a semester or two before they offer a RA position. This goes for both teaching as well as research assistants. The university restricts your employment to 20 hours per week if you are on an assistantship. So we occasionally have a student who thinks, okay, well, I'm going to get a TA position in the ECE department, and then I'll go over to the math department and get one there, and then I'll try physics and I'll get one there, and I'll be doing 60 hours per week and making lots and lots of money. Well, you might get away with that for a couple of weeks, but eventually somebody in the university is going to figure out that you've exceeded the 20 hours per week total of employment, and so you were going to lose maybe all of those assistantships. So you need to notify all departments involved. Indeed, you could have a teaching assistantship both in ECE and in the math department, but the sum of those hours has to be less than 20 hours per week. So you need to involve all the departments and say, hey, I'm working 10 hours in ECE, can I pick up 10 hours in your department? So that everybody knows. Additionally, you can't go to Starkville and start working at McDonald's, for example, for 30 hours a week. The maximum of 20 hours a week, you can't be employed outside the university unless you get prior approval from the Office of the Graduate School. If you're making less than $600 a month, you're technically not on an assistantship, you're going to be on wages, and we'll talk about student worker positions in a little bit further down. Okay, again, if you fall onto academic probation, you can't hold an assistantship, and you can get your assistantship terminated if you if your grades are below a B, or you get a 3.0 or below in your any semester. Okay, if you are going to have assistantship support in the summer, then you're going to need to be registered as a full-time graduate student, 13 hours, unless of course you're taking this out, for the subsequent fall semester, unless you happen to be graduating during the summer. All right, if you're an international student, you have to have a current I-9 on file with the university to be employed. Any questions about assistantships? Okay, you'll be filling out a lot of paperwork as a graduate student, and two of the most important forms, you will be encountering those later in the semester. These are the committee request forms and the program study forms. Yes?
Quick question on the
Yes.
assistantships. The funding for assistantships, does it come through till later? Is there a set date on those?
What do you mean the funding?
So like for, this August 1st was technically for everybody else. We're not held to that, are we, from my understanding? We're exempt from the August 1st.
Okay, yeah, you're talking, yeah. At the moment, you guys are exempt from having to pay August 1st because your assistantship doesn't actually start until the 16th of August. So I'm assuming that that's the way that's going to be going forward, but this is a big new change for the university in terms of having this earlier deadline. So we'll see how that works out. They'll probably make changes to that for next year. We were very concerned when they implemented this that it would negatively impact our incoming graduate students, but for right now, I think everything's okay. Nobody's had any problems so far. Oh, good. Okay, so program of study and committee request forms. So let's actually go and take a look at those forms. Here's the committee request form. Okay, there we go. Okay, so you will, as a graduate student, have a committee, and the number of faculty members on your committee will vary depending on whether you're a master's student or a PhD student. So we'll talk about the specifics of those when we talk about the specifics of the master's and PhD degrees. The most important person on your committee is your major professor. This is going to be your primary advisor. You will most likely be doing research with that person as well. And so finding your major professor is something that you want to do as soon as you can, because that will permit you to get started on research as soon as you can. Your major professor is also going to help you decide on what classes to take each semester. And since you will be registering for classes for the spring semester around the October timeframe this semester, you would really like to have a major professor guide you in making those selections. And so you'll want to get a major professor as soon as you can. So this form here tells us who your committee is. You'll have a major professor, and then you'll have several committee members as well. You may also have a minor in addition to your degree, which is of course going to be electrical and computer engineering. If you have a minor, and a minor is optional, you'll have a minor professor. And so this form is filled out with the signatures of the major professor and the rest of your committee. And then down here, you sign as well. And then I sign as the last person. And this then is a document that says that everybody here agrees that this is your committee. The committee agrees, you agree, I agree, we all agree that this is your committee. If you have a minor, you also get a signature from the minor graduate coordinator. So that's the graduate coordinator in the department that has that minor. They also agree then that this is your committee. And so we would like for you to get this committee request form filled out early this semester. If you have trouble finding a major professor, we can give you a waiver and let you fill this out next semester. But things will go much easier for you the sooner you get a major professor. And the major professor will help you figure out who the remaining committee members will be. And so that should be one of your goals early in this semester, is getting that form filled out. The program of study form is another form. This tells us what classes are going to constitute your degree. So graduate school is a good bit different than undergraduate degrees. In most places, an undergraduate degree is almost completely prescribed to you. You have to take course A, B, C, etc., all the way down. You may have a few options, a few technical electives, but by and large, the majority of your program is set. You have to take all of these classes, and when you take all of these classes, you get your degree. Graduate school here in our department is completely different. We have no required classes. It is up to you and your major professor, as well as the rest of your committee, to determine what classes are going to constitute your degrees. We have a few rules that have to be satisfied, and those differ depending on whether you're a master's student or a PhD student, so we'll talk about those specifics when we get to it, but this is where you list all of the courses that are going to constitute your degree. And so you fill that out, your major professor and your committee sign, you sign down here, I sign here as the graduate coordinator. I'm always the last person to sign, so you get all the other signatures first. Don't forget to sign yourself, and then I will sign. And this basically constitutes a contract that says that if you take all of the classes listed here, this will be sufficient for you to get your master's degree or your PhD degree. Now, of course, we're going to ask you to fill this out this semester, and it's going to be hard for you to anticipate or predict what courses you want to take. If you're a PhD student, you're going to be taking courses over quite a few years, and you don't know what you want to take over 3 years from now or 4 years from now. Master's student, okay, a shorter period of time, but still 2 years from now, you don't know necessarily what you want to take. So with the help of your major professor, this is going to be initially more of a wish list of these are the courses I would like to take, and if I do take these, then that's going to be sufficient for your degree. You can change this program of study at any time. We have a change of program of study form. Bring that up. I think I have it listed here, but I can very quickly get to it here by going to our graduate program, and then all of the ECE forms are right here. And you see right here the graduate program of study and the change to the graduate program of study. And so to change the form, it says it's a very similar form. You add courses to the program of study and you delete them here. So there's two sections. And this says add these courses, take these courses off. And then again, signed by your major professor, signed by your committee, signed by you, and signed by me. And so ultimately, you will change your graduate program of study probably several times. That's typical for students because we have new professors come in. New professors will create new classes, and you'll see it and say, "Oh, I would really like to take that class, but it's not on my graduate program of study." Not a problem. You just submit a change of the graduate program of study, and you can substitute in that new class for one of the other classes that you haven't taken yet. We have professors who leave and they teach classes, and maybe we don't have anybody else that can cover that same class, and so some classes will disappear. And if those classes are on your program of study and you haven't taken them yet, you're going to have to find something else to take. So you'll be submitting a lot of these change of graduate program forms over the semester, but it's not a big deal. We just have to get everybody's signature here. Any questions on this paperwork? Like I said, we'll want you to fill these out this semester. Yes?
Is there a procedure to change, let's say, a committee member in case they leave university? Do you have?
Yes, there is a change of committee form as well. So if we go to, what is this? Okay, so this is the Office of the Graduate School website, so any form that is not available at the ECE website, you can find here. So you go all the way down to the bottom here. Got forms, here it is. These are all the university level forms, and so the committee request form is found here, and the request for change in committee form is found here. So indeed, when faculty come and go, you may want to make a change to your committee, and the form to do that is very similar to the program of study form. Basically, there's a section to add people to the committee, and there's a section to remove people from the committee. And the slots here will tell you, you're moving this person, or you're adding this person as your major professor, or you're adding this person as a committee. So if you want to, say, change your major professor, this is how you would do it. You would remove the person who's currently your major professor here, and then you will add the new major professor there. And this, of course, will require signatures from all of the faculty members involved in the change. So if there's a faculty member who's on your committee and that person is not changing, that is not being added, not being deleted, then their name does not need to appear on here at all. And in fact, it should not appear on here. It's only the people that are being added or removed. And each one of them has to sign, indicating that if they approve of that signature, that change, you sign as well, and then finally I sign. So that's how you can change your committee. This happens, it's somewhat rare, but it does happen from time to time. Any other questions on the paperwork? Okay. All right. So let's go. Let's go back to. Starts back at the beginning, doesn't it? Okay, so program of studying committee request form, we just did that. Registration for courses. Typically, in fact, for every semester except for this semester, we require you to pre-register for courses. And so for the upcoming spring semester, you'll need to register for courses around the October timeframe. There'll be a notification sent out as to when you can register, but it'll be around October. In order to register, you will need to get a registration release. There'll be instructions on how to get that release sent out by email when it's possible for you to register. And the way that is done is that you will send an email to Ms. Cheney. Ms. Cheney is my assistant. She will look in your folder to see whether we have the committee request form and the program of study form for you on file. And if we do, she will then release you for registration. So a very simple process. You just send the email to her and she will release you. And so that's why you want to get the committee request form and the program of study forms completed before pre-registration begins. Like I said, if you have problems getting a major professor, we can let these forms slide until the next semester, but you'll need to contact me and we'll have to arrange to get your registration release done differently than through Ms. Cheney. Now, we do require that you register for classes by the last day of classes of the preceding semester. So for the spring semester, The last day of the fall semester is the last day that we permit you to pre-register. We want you to register though as soon as you possibly can. A lot of graduate students think, well, I'm going to wait until the next semester starts. I'm going to go to a couple classes and then I'll decide which ones I really want to take. Well, don't do that. Sign up for classes before the semester starts. In fact, sign up for classes before the current semester ends. The reason that we want you to do that is because courses will be canceled if their enrollment is low. We need to have a minimum of 5 students in a class at the graduate level for it to make, that is, for it to not be canceled. We start canceling classes right after the end of the current semester. So spring classes, they'll be on the catalog up until the last day of fall semester. But then in the first several weeks of December, courses that have low enrollment will be canceled. So if you're, say, thinking of taking a class, there's only 4 people enrolled in it, and you think, I'm going to wait until January, until the spring semester starts, and then I'm going to look at that class, I'm going to look at 2 or 3 others, and then I'll make a decision as to which one I'm going to sign up for. Then the chances are that since there's only 4 people currently enrolled in that class, it's going to be canceled. And you're not going to have the opportunity to take that class because when it comes to be January, you're going to go and try to find the class and it's already going to have been canceled. And in fact, not only are you not going to be able to take the class, but those 4 people who signed up for it, they're not going to be able to take the class either. So it's not just about you and your schedule, it's about all of your fellow students as well. Because when that class gets canceled, those 4 other students are going to have to find something else to take. Yes, you have a question?
Is that a department policy that it has to be canceled if it doesn't make?
No, universities starts looking at classes with low enrollment,
But
below 5.
could the teacher decide to do it even if it was low enrollment?
Well, if it's over 5, the teacher could still say cancel the class, or the department head. Ultimately, it's really kind of the department head's call. If the teacher or the department head could cancel the class even if they were 20 enrolled, if there was some sort of extenuating circumstance. But anything below 5 is going to get canceled by the registrar. They're going to start looking. They won't immediately cancel it, but they're going to inquire to the college. Why is this class still on the books? There's only 3 people enrolled. The college is going to inquire to the department head's going to inquire to the instructor, and it's eventually just going to get canceled. The thing is, though, is that say there were 4 people enrolled in that class, and you thought you might want to take that class, but there's this other class you might want to take. You can't take both of them because you've already got enough classes on your schedule. You're only going to take one of them. Well, sign up for both of them. That gives 5 people in that current class. And even if you drop it in the first week and it goes down to 4, it doesn't get canceled. That's the trick. The course can still proceed because the university is not likely to cancel the class. I mean, they could during the first week. They could cancel it, but they're not going to. So do that. Sign up for more classes than you need, and then drop the ones that you are not going to take. So you're only going to take maybe 3 courses in a semester. Sign up for, if there's 5 that are interesting, sign up for 5 and then drop 2. Don't sign up for none and then sign up for 3 during the first week. Okay? Because like I said, these course cancellations don't just affect you, they affect all of the graduate students in the department. We want as many of these courses to make as possible. Now some classes it's not going to be an issue, there's 20 or 30 people in them, but classes that have low enrollment, they will get canceled. And so keep that in mind. Any other questions? Okay, next issue, report of examination forms. Like I said, the degrees all have a number of examinations that these will take place, and when they do, they have to be documented with this form. The only thing I want to point out here is that you as a student are forbidden by university policy from handling this form. So a lot of times a major professor will have collect all the graduate paperwork together after, say, your master's thesis defense, and they'll just hand the stack to you and say, here, take all this to Dr. Fowler. But you need to be cognizant that all of the paperwork you can handle except for the report of examination forms. It's your major professor's responsibility to get that form to me, so they might as well be giving all of the forms to me. So. Okay, schedule changes. Like I said, you can drop classes. You can also add classes pretty much during the first week of the semester. You can adjust your schedule at will. You can do this very easily in the Banner system, the same system that you use to sign up for classes, and the same system that you'll be signing up for classes using later today. There are deadlines though. The drop deadline is the 5th day of the semester, and the add deadline is the 6th day of the semester. And if you go past these deadlines, then making changes to your schedule is possible, but it is difficult to do. There is a form that has to be filled out in order to do that, this form from the registrar. There's also a checklist that the college makes you fill out, so there's 2 forms basically. And there will be a fee as well. It's, I believe, $50 per class. So I need you to know when these deadlines are. I will be sending out an email on the very first day of courses on every semester that has exactly when these deadlines are. So you want to look at that email, look at when those deadlines are, and know that if you are making changes to your schedule, you need to abide by these deadlines, because doing these late adds and drops are difficult. They don't make me happy. They don't make the people in the college happy. They don't make the people in the registrar's office happy. You don't want all of these people to be unhappy with you, so abide by these deadlines. Okay, student worker positions. We mentioned that earlier. Any student that's paid less than $600 a month is considered a hourly wage employee or a student worker, and is not on an assistantship. You do, however, need to be registered during that semester that the wages are received, and in order to get wages in the summer, you do have to be registered for the subsequent fall semester unless you are graduating in that summer. You do have to have a current I-9 on file if you are an international student. Okay, U grades. U grades, this usually only applies to ECE 8000 or ECE 9000. These are 2 courses that deal with research, and they are graded as U or S. So if you make unsatisfactory progress in your research, you may get a U grade from your major professor for that research. And if you get a U grade in the research in your next semester, that will result in your dismissal from the program. We have a special form called the research hours U grade form. So if the major professor is giving you a U grade for your research in that current semester, you and the major professor have to fill this form out. It basically documents what you need to do in order to get an S grade in the research hours in the next semester. And so you sign it, the major professor signs it, I sign it, so everybody is on the same page. Everybody has a clear understanding of what it's going to take for you to not be dismissed from the program. Hopefully, you'll never encounter that. Unclassified students, that doesn't apply to any of you because you are all ECE students. Okay, and so that is the conclusion of all the general policies and procedures that apply to everybody in graduate school. We'll next go into the specifics of the master's degree and the PhD degree. But first, are there any questions that anybody has on these general policies and procedures? Okay, so let's talk about the master's degree. We'll go through that first, and then we'll go through the PhD degree. There is a lot that's very similar between the two degrees, so there'll be some repetition, but there's a few things here and there that are quite different between a master's and a PhD degree. So how many of you are master's students? Can I see a show of hands? Okay, about half. Okay, so you already got admitted, so that's not an issue, so we won't talk about that. Course requirements. Okay, so this is an important thing to note, because as you're filling out your program of study, this is what tells you the things that your program of study must satisfy. Like I said, we have no required classes. We just have a few rules. So, as a master's student, you have the option of either pursuing a thesis or not pursuing a thesis. The non-thesis option is a courses-only master's degree, and it consists of 10 courses. So all of our graduate level courses are 3 hours, so 3 times 10 is 30 credit hours. So that's the requirement for your program of study. It should have 30 credit hours listed on it. That is exactly 10 courses. Now, if you're a thesis student, in addition to taking courses, you will also be doing research with your major professor. You will only be taking 8 courses, and so that's a total of 24 credit hours of coursework, but then you'll need 6 credit hours of ECE 8000. ECE 8000 is the thesis research course that you put on your schedule to document the fact that you are doing research. And you need 6 credit hours. You can exceed 6 credit hours. In fact, most master's students do go over that, but you need it at a minimum of 6 credit hours of ECE 8000. So the 6 hours of research plus the 24 hours of courses, that gives a total of 30 credit hours beyond your bachelor's degree. So both the thesis and the non-thesis require 30 credit hours. The only difference is whether you're taking the research or not. Now we have some general requirements that apply to both the thesis and the non-thesis options. Courses at the graduate level, we have 6,000 level courses and we have 8,000 level courses. 6,000 level courses typically are courses that are offered both at the same time to undergraduate students and graduate students. So we go into the classroom. Some of the students in there will be undergraduate students, some will be graduate students. The graduate students take the 6,000 level version of the class. The undergraduate students take the 4,000 level of the class. But other than that, the course is pretty much the same. Same instructor, same homework, same exam, etc. Courses at the 8,000 level are graduate students only. There will only be graduate students in those courses. So half of the courses must be at the 8,000 level. So if you're taking a non-thesis master's, you will be taking at least 5 courses that are at the 8,000 level. If you are doing the thesis option, at least 4 of those courses will be at the 8,000 level. Now, of course, you could exceed the requirement. You could take all of your courses at the 8,000 level, but at least half of them is the requirement that they must be at the 8,000 level. Now, a lot of students ask me, well, is a 6,000 level course easier than the 8,000 level course? They're often scared about the 8,000 level course. And no, that's not necessarily true. The 6,000 level course is going to be on material that is not as sophisticated as an 8,000 level course, because there are undergraduates that are in that same class that are taking that same material. So it's not going to be probably as in-depth. The amount of work, though, might be fairly high. You may have a lot of homeworks, you may have a lot of exams. The 8,000 level courses tend to be very much in-depth. They're very sophisticated, they're very highly focused on a very specific area of study. Doesn't mean that they're necessarily harder. You may actually find them sometimes to be easier. It depends on what you find to be easy and what you find to be hard. You may not have very many exams. There may not be any exams. You may have to do a research term paper or a presentation or something like that. You may have exams and have to do a research paper. Who knows? It all depends on the particular class. But it'll be different, but not necessarily harder or easier than the 6,000 level course. You really can't make the judgment that way. Okay. You can take directed individual study. You're not required to. You can have up to 6 credit hours of directed individual study. Since the directed individual study classes are 3 hours each, that means you could take up to 2 separate sections of directed individual study. Of course, you can't take them in the same semester. They would have to be in 2 different semesters. Now, ECE 7,000 is the number that we give to directed individual study. And if you go back up here, you say, well, is that a 6,000 level class or is that an 8,000 level class? Well, it's neither really in terms of its number, but we count that as an 8,000 level course when it comes to satisfying this requirement here, that half the courses must be at the 8,000 level. So we account 7,000 as an 8,000 level course when it comes to this requirement. Yes?
If you're taking 6 hours of research, does that count for your 8,000 levels?
No. Those are research hours and coursework hours. This rule talks about coursework. Okay, you can take courses outside of the department. You don't have to take everything in the ECE department. Up to 9 credit hours can be taken outside of the department. However, you do need to get these hours approved in advance of signing up for them. And by approved, basically you need to get my okay as well as your major professor's okay. So don't go off to the business college and sign up for some management class and then say, I want to put this on my program of study. I'm going to say no. I'll tell you that right now. I'm going to say no. But if you've already taken the class, then you've basically wasted that class. You don't want to take something that's just not going to be on your program of study. So make sure you get the approval before you sign up. Now, if you take all 9 credit hours in the same department, you can declare a minor. So a minor requires 9 credit hours to be taken from a single department outside of ECE. So math is a very common minor. So if you take 3 math courses, you can declare a math minor. Now, the out-of-department courses that are cross-listed with an ECE course can't be used as a minor. Why? Because we've already told you you've got to take the ECE listing of that course, and so it's not an out-of-department course. You can only have 1 minor, and a faculty member from the minor area must be on your graduate committee. And then finally, the minor is controlled by the minor department. So if you want a math minor, you have to go over to the math department and find out what it takes to get a math minor. They may say you have to take courses A, B, and C. They may have a specific set of 3 courses that you have to take. Or maybe you can take any courses, but at least one of them has to be at the 8,000 level. Or they have a special seminar class that you have to take. It is up to the minor department to determine what criteria is in place for them to award a minor. And so you have to find out from them what their requirements are. They may not even offer a minor. Some departments do not. We in ECE, for example, do not offer a minor. Computer science does offer a minor. That's a common selection for some of our students. Math also offers a minor. That's also fairly common. A minor is optional. Even if you take 3 math courses, you don't have to call those 3 math courses a minor. You can if you want to, or they can just be 3 out-of-department courses. You don't have to declare a minor. If you do want to have a minor, though, the out-of-department courses must all be from the same department. Any questions on this? Okay, so a lot of these rules are very similar to the rules we'll see for the PhD program as well, with just a few slight variations. Okay, so in general, if you want a course to be counted towards your degree, it has to be on your program of study, and it must be approved by your graduate committee as well as me. And it has to be done so in advance. So this is particularly important for courses that are outside of the department. You need to get those approved in advance before you take the course. Now, as a general rule, almost everything in the College of Engineering is going to be okay. I will approve that for you to take. Almost everything. Almost everything in the math department is going to be fine as well. Everything in the College of Business is not going to be fine. And pretty much anything outside of engineering, you might find a few courses that'll be okay, but very few. Now, here's some exceptions to what I just said. These specific courses, these three in the math department, these cannot be included on your program of study, as well as the CSE course. Why is that? Well, our undergraduates in our department basically take the equivalence of these 4 courses. And so this is material that we feel that you as a graduate student already should have had as an undergraduate, regardless of where you did your undergraduate degree. And in fact, you probably have already had this material in the past. So these courses cannot be counted towards your program of study or towards your degree. But most everything else in the College of Engineering and in the math department is going to be okay. Any questions on this? Okay, examinations. Okay, so for a master's student, you have a couple of examinations. Actually, if you're a non-thesis student, you just have the one. It's called the comprehensive examination. This is an oral examination that takes place in your last semester. So you have to be, according to the university, within 6 credit hours of completing your coursework, you have to have a GPA of at least 3.0. Effectively, you will schedule the comprehensive examination with your major professor. You go to your major professor and say, I'd like to take my comprehensive examination this semester and graduate. This examination has to be scheduled 3 weeks prior to it actually taking place. And there's this announcement form that has to be filled out as well. The way the comprehensive examination works is that the committee draws up a list of 6 topics that cover the student's coursework. That list of 6 topics is given to the student no later than 2 weeks before the oral comprehensive examination. This gives the student some time to review that material from the course. And then on the day of the examination, the committee selects 3 out of those 6 topics and then asks questions of the student orally until everybody gets tired and wants to go home. So that's pretty much it for the examination. It's oral. There's a couple of forms that are filled out, report of examination form, etc. And these are all given by the major professor to me. Now, it's very rare, but we occasionally have a student who will fail this exam. Almost never happens. If it does happen, though, you will be allowed to repeat the examination, but you have to wait 4 months. So you probably need to spend that time of 4 months studying your coursework and getting up to speed on it so that you can take the exam again. You only get 1 extra shot, so a total of 2 chances to pass this exam. If you fail on the second attempt, then you are dismissed from the program. Okay. If you are a thesis student, then of course you are going to be doing research, and you will be defending that research orally in front of your committee. And so that is the thesis defense. So the thesis document, which I'll talk about in just a second, must be completely finished and given to the major professor, and that must be done 2 weeks at least before the defense, and it needs to go to the committee at that time as well. You also submit it to the Safe Assign facility inside my courses, and instructions are sent out at the beginning of every semester as to how to do that. You do have to be enrolled when you do your thesis defense. And if you fail the thesis defense, you can do the defense one more time, but you do have to wait 4 months before you can do that. And a second failure will get you dismissed from the program. In addition to the thesis defense, which is an oral presentation in front of your committee, and then fielding questions on your research work from the committee, there is the thesis document. Your master's thesis is a formal research paper that is presented by you to graduate faculty for your degree. It has to be approved by your graduate committee. In fact, there's a signature page where all the committee as well as myself have to sign. And then finally, the thesis must be submitted electronically through the Office of Thesis and Dissertation Format Review, which is part of MSU Libraries. They make sure that all theses that come through are properly formatted. So there's a bunch of deadlines as to when this goes through, because you have to do an initial submission, and then you'll get a whole bunch of criticisms back. You have to make changes, and then they'll have to go back to the library for final approval. It is expected that the work leading to a master's thesis constitutes a research contribution that is of sufficient novelty and significance to warrant submission of at least one article to either an archival journal or to a conference proceedings. So it's very strongly encouraged that if you are a thesis student, that you work with your major professor to get that work submitted to either a journal or a conference before you leave the university, because it becomes much harder to do so after you leave the university. And when you make that publication, do document that in the graduation form as well as the exit survey from college. Okay, your committee. As a master's student, you're going to have a major professor and then 2 committee members. The committee members, one of those will be a minor professor if you do have a minor. So it is possible for one of those committee members to come from outside of the department. The major professor, however, must be an ECE graduate faculty member. If you are a full-time student, you need to get your major professor and graduate committee selected during your first semester of enrollment. If you are a part-time student, i.e. a distance student, then you will need to get that done the semester after you complete 9 credit hours. And if you do need to change your committee, of course, there was the request for changing committee form that we saw previously. Finally, prerequisite courses. If you are coming in from an undergraduate degree that is not in electrical engineering or computer engineering, chances are you were given some prerequisite courses that you needed to satisfy before you can get your degrees. And this is a bare minimum of the courses that you need to be taken at the undergraduate level if that was the case. And there may be other courses as well. But you can take these pretty much at any time during your graduate career, as long as if you're taking a graduate course, you have to, of course, satisfy any undergraduate prerequisites that that course may have. Transfer of credit. You can transfer courses that you may have taken at another institution, but you're limited to 9 semester hours, and you cannot transfer anything that was taken at an institution outside of the United States. Okay, we don't need to talk about the accelerated program, which is basically a combined undergraduate degree and a graduate degree. Okay, then finally, the last 2 pages of the master's section has a timeline that shows you everything that you need to do and when you need to do it, more or less, to get your degree. Okay, so these are the things for the non-thesis option. So submit committee request form, submit graduate program and study form. These need to be done the first semester of enrollment, so we've already talked about that. As a non-thesis student, there's pretty much nothing else that you really need to do other than take your classes until you get to the last semester of your enrollment. And the things that you'll need to do then to graduate, there's an application process to apply to graduate. There are certain deadlines for that, and those will be sent out in an email every semester at the beginning of the semester. You can also find those on the academic calendar as listed on the grad school's website. You'll take an oral comprehensive examination, so 3 weeks before that examination is to take place, it needs to be scheduled. You work with your major professor to do that, to find a time that everybody on the committee can be present for, and the major professor will get your room scheduled as well. There's a declaration of announcement of the comprehensive exam form that also needs to be done 3 weeks before the comprehensive examination. You take the comprehensive examination, and then the major professor submits all the paperwork to me, then there's well, a bunch of paperwork, and then that's pretty much it. Okay, so for the thesis option, again, first semester of enrollment, you're completing the committee request and the graduate program study forms, and then you're doing nothing to doing your coursework and your research work up until the last semester of enrollment, where you apply to graduate, you schedule your thesis defense, you announce the thesis, you submit the declaration form. All of that has to be done 3 weeks before the defense. The thesis has to be read and approved by the major professor and then submitted to the graduate committee 2 weeks before the thesis defense. At that same time, you have to get the thesis into the safe assigned facility inside my courses. And then finally, you do your thesis defense, and if you're successful, then you'll graduate. Either way, you'll have a whole bunch of paperwork that you get to me immediately following the defense. You'll also have to get the signatures on your thesis signature page. So your committee has to sign that, I have to sign that, the college has to sign that, and then it has to go over to the library before your first submission of your thesis. So you need to check the graduate calendar for the exact deadlines of when things need to get done, and check the thesis signature checklist that the college publishes as well, so what it takes to get the college signature on your thesis. And then finally, you submit the final thesis to the MSU library. Okay, that wraps up the master's program. Are there any questions about the master's degree? Yes?
Can you do your thesis at any point, your thesis defense at any point in your career, or is it, I mean, it's probably generally closer.
It has to be done, I believe it has to be done within 6 hours, if that's.
The non-thesis said that, but I didn't see the
Yeah.
thesis saying that, maybe it did.
It doesn't say it here. That may be a university deadline. It's almost certainly going to be, you're going to generally have finished all of your coursework, and that last semester or two, you're probably just going to be taking research hours to finish up. That's when most people finish up. So it is usually can knock out the coursework faster than you can knock out the research. But I don't know if there's actual, I'd have to go to the university document to see if they have that same 6 credit hour policy. Other questions? No? Okay, let's move on to the PhD program. We just need to talk about admissions. Course requirements. Okay, so if you are a PhD student, you either have a master's degree already or you don't. And so if you have a master's degree, then you fall under this category here, or admission from the master's degree. And this category of student requires 48 credit hours beyond the master's degree. Okay, so that's a minimum. Your major professor and committee could require you to take more than 48. It's rare, but it could happen, but 48 is the minimum. 24 of these credit hours are going to be coursework, and so that's going to be 8 courses. And 24 credit hours are going to be ECE 9,000, which is the dissertation research hours. Now, this is a good time to point out the difference. ECE 8,000, ECE 9,000. If you are a master's student, you take ECE 8,000. If you are a PhD student, you take ECE 9,000. Now, they're both research, and to your major professor, there's no difference between doing research and calling it 8,000 and doing research and calling it 9,000. However, to the university, it is a difference, because the university says that a PhD student has to have 24 credit hours of 9,000. If you make a mistake and sign up for 8,000, well, you still do your research, you have 8,000 on your schedule, but when it comes time to graduate, the university will say, oh, you took 21 credit hours of 9,000, but that one semester you took 8,000 rather than 9,000. You can't graduate because you don't have enough credit hours of 9,000. And you say, well, but I took 3 hours of research, can't I call them 8,000, 9,000? And the university says, no, 8,000 is not 9,000. Same thing goes with a master's program. If you sign up for the 9,000 hours instead of the 8,000 hours, then the university says you can't graduate because you don't have 6 hours of ECE 8,000 on your transcript. And you say, well, I took 9,000 by mistake. And the university said, sorry, you can't graduate. So be very sure that you take the right section. If you're a master's student, you take ECE 8,000. If you're a PhD student, you take ECE 9,000. If this was a perfect world, your major professor would catch it if you make a mistake, but I will tell you right now, your major professor will not catch it. I asked them to look, but they don't look. So it's up to you to make sure you get it right the first time. Okay. 24 credit hours of coursework, 24 credit hours of research if you already have a master's degree, so you've been admitted from the master's program. Now, if you have what we call direct admission, which is you have a bachelor's degree only, then you're going to have to take 66 credit hours beyond your bachelor's degree. 42 credit hours of this is going to be coursework. That comes out to be 14 courses. And 24 credit hours of ECE 9,000 research. Now, we have some general requirements, and these are effectively the same requirements that we saw at the master's level. Half the courses must be at the 8,000 level. So if you have a master's admit, half of your 24 credit hours, that's 12 credit hours for 4 courses, has to be at the 8,000 level. Now, if you have a direct admit from the bachelor's degree, half of these 14 courses are going to have to be at the 8,000 level. That, of course, is 7 courses at the 8,000 level. You can take directed individual study. You can have up to 6 credit hours of directed individual study, and even though those are ECE 7,000, you can count as 8,000 level for the preceding requirement. And you can take credit hours from outside of the department. The PhD student is permitted to take up to 12 credit hours outside of the department. The limit, as you recall, for a master's student was 9. To do a minor, and very similar to the master's program, but for the PhD student to have a minor, you have to take 12 credit hours from that single department. And at least 3 hours must be at the 8,000 level. Other out-of-department, the out-of-department minor may have a specific requirement in and above this requirement. Again, cross-listed courses can't be part of the minor. You can only have one minor, and you will have a minor faculty member on your committee, just like you did as a master's student. Okay. Again, courses taken from outside of the department must be approved in advance by me, and these same courses are not applicable to a PhD program as well as a master's program. Okay, now if you're a PhD student, you're going to be taking multiple examinations. The first one of these examinations is the qualifying examination. The qualifying examination must be passed if you are a full-time student during your first 2 years of enrollment. Now, we offer the qualifying examination one time during the fall semester and one time during the spring semester. So over those 2 years, we'll have a total of 4 opportunities to take the exam. The exam is given twice a year. It is usually the first Saturday in October and the first Saturday in March. But of course, we don't have a qualifying examination the day of a home football game. That would just be chaotic and insane. So we work the fall examination schedule around home football games. I will be sending out an email this week as to when that qualifying examination is going to be held this semester. The qualifying examination has to be passed if you are a doctoral student. And it has to be done in the first 2 years of enrollment as a full-time student if you are a full-time doctoral student. If you are a part-time student, then you have 4 opportunities to take the exam after you have completed 9 hours. So be sure to do that and not forget about it. Additionally, you can take the qualifying examination if you are a master's student. And in fact, if you are a master's student and you are thinking that you may go on to be a PhD student at some time in the future, I would recommend that you take the qualifying examination while you are still a master's student. The benefit of doing that is that, one, if you pass it as a master's student, that is done. You're done. You don't have to worry about it again when you become a doctoral student. Additionally, the qualifying examination is over undergraduate material, and as a master's student, you're going to be closer, temporally speaking, to that material than you will be when you become a doctoral student in the future. So the material is going to be more fresh on your mind. And then the third reason is that there is no limitation as a master's student. You'll be a master's student for probably about 2 years. The exam will be offered 4 times. You can take the exam all 4 times. If you don't pass it to those 4 times, then you become a doctoral student. You'll have 4 more opportunities to take the exam. So you can take the exam as many times as you want to as a master's student. It's only when you become a doctoral student that you have that window of time in which you have to pass the exam. So indeed, you should, if you think that you're going to go on for a PhD, you should take and pass that qualifying examination as a master's student. Okay, refer to the departmental website for more information on this exam. Okay, so let's do that because as a PhD student this semester, you should probably consider taking this exam. Okay, so get over to that quickly. Okay, so we have a page dedicated to the qualifying examination. I want to point that out to you right here. So this gives you an overview of the exam. If you want to take the qualifying exam, we have the qualifying exam form, which basically is just a very short form that tells me that yes, you want to take the exam and you plan on showing up for exam day. That way I'll have as many exams as I need, and I'll be able to give you a code because you don't put your name on the exam, you have a code that's given to you to put that on. So the deadline for submission of the qualifying exam form, that is to sign up for qualifying exam for the fall semester, is September 15th, and for the spring exam is February 15th. So you want to be sure about that deadline. I'll be sending out information this week on the qualifying exam by email. The exam itself consists of a total of 25 problems that are drawn from our undergraduate curriculum. 12 of those problems come from what we call the lower level core courses. These are things like signals and systems and circuit analysis. 13 problems come from discipline-specific upper-level courses, things like communications theory, signal processing, that kind of stuff. The exam takes place on a Saturday morning. It's 4 hours long. You have to work 8 problems, 2 as a minimum out of the upper level, but the other 6 can come from either the upper level or the lower level. You turn in those 8 problems for grading. So an example exam is given right here, so you can click on that. And this is an actual exam that was given a number of years ago. The exam that you have will have different problems, but it'll be exactly like that. You can have a basic calculator on the exam, and this calculator policy tells you what that constitutes. And so these are the courses that are taken, even if you didn't have your undergraduate degree here. These should all look very familiar to you. And if you click on the link here, this gives a overview of what is covered in that class. To get more detailed information, you can email the instructor that is teaching that class this semester. They may be able to provide you this semester's syllabus, sample exams, homeworks, things like that. Or you can talk to some of the professors who've taught it in the past. I myself, on my webpage, maintain the current signals and systems and introduction to circuits and material. So it's there for you. Other professors may or may not be as forthcoming in providing you material, but it doesn't hurt to ask to see what you can get. Okay. All right, so I guess that's pretty much it that we need to talk about the qualifying examination. Let's go back to the okay, so that's the qualifying exam. After you pass the qualifying exam, that's the one exam that takes place early in your career as a PhD student. The next exam is technically called the oral preliminary examination, but more frequently is called the dissertation proposal defense. And so this exam takes place about the time that you finish your coursework as a PhD student. In fact, you are required to take it and be within 6 hours of finishing your coursework. So it's usually done in the last semester of your coursework or shortly thereafter. And what it is a proposal of the research. So you will probably at this point have done some research, but you will not have completed all of the research that's going to be required of your dissertation. So you give an oral presentation of your research. You tell the faculty that are on your committee what you have done and what you anticipate doing, and if the faculty agree that this is going to constitute reasonable work for a dissertation, then they will pass you and you'll be given the green light to go ahead and do this research. They may have some suggestions that say, okay, well, what you're planning to do is not going to work out. You may want to try this other track, something like that. You will also write a proposal document that has to cover, tell what your specific research topic is, give a review of the literature, what your proposed method is, and then present any preliminary results that you have. And most of the time, this proposal document is going to be the first 1 or 2 chapters of what becomes your dissertation, and so you'll probably be writing it in the format of a dissertation, and then just expanding on that as you go to complete your final dissertation. Okay, so the preliminary examination is scheduled by your major professor, and it has to be set 3 weeks in advance of the actual date that the examination takes place. It has to be attended by your whole committee. There's a report of examination and the other paperwork that's filled out for that, as well as the admission to candidacy form if the committee feels that you're ready to go into the final stages of finishing your dissertation. It's rare, but if you do fail the oral preliminary examination, you can repeat it, but you have to wait 4 months in order to do so. And a second failure will dismiss you from the program. Okay, it's not possible for you to do your proposal defense in the same semester as your final defense. The university requires you to wait about 6 months between doing the proposal defense and the final dissertation defense. So if you want to graduate in, say, December, then your preliminary examination, that is your proposal defense, must be done by July 1st in order to be able to graduate in that fall semester. For spring graduation, you have to get your proposal done no later than November 1st of the preceding fall semester. Okay, and then finally is the dissertation defense. We won't go into a whole lot of detail here because it's basically the same thing as the master's thesis defense. Only a dissertation is just a much longer document and a much more in-depth study that you've done. But the process is pretty much the same. 3 weeks before the dissertation defense, you have to schedule the defense. 2 weeks before, you have to get the document to the major professor and to the committee, and it has to be submitted to the safe to sign. And you can fail the defense and retake it, but you have to wait 4 months, and a second failure dismisses you from the program. Any questions about any of the examinations that go on with the PhD program? Yes?
It's not about the examination. I just wanted to ask if we can audit the courses as well, if not credit.
Audit which courses? The any courses?
Main courses. If like for in this semester, since I have a qualifying examination, so if I want to prepare for that, so can I go and just audit the other courses and not take it?
Right, so the undergraduate courses is what you're saying. You have to ask the instructor for those courses to see. They may let you do that. Theoretically, the university requires that every person in the room be registered in some form or fashion, and so a formal audit is what the university would require, which means that you register for the class and then you change it over to an audit. But the professor may violate university policy and let you just sit in the class and listen. The issue that you're going to run into, though, is that by the time of the qualifying exam, which will be very late September or early October, you will only have gotten half the course in, and so the utility of that may be questionable. Now, you could do that for and take the qualifying exam in the spring, but you're only probably going to get about half the course before you have to take it in the fall. So along the lines of the qualifying examination, I should also point out that it is a hard exam, but you can pass it. Not everybody passes it their first try. About half of the students who take it in any given semester will pass it on their first try. That the other half of students, they'll go into and take it again for a second attempt. And almost everybody passes it by the time of their second attempt. We have a handful of students, a very small fraction, that go on to a third attempt, and an even smaller fraction that go on to a fourth attempt. And in all the years that we've been offering the exam, I can only think of, maybe 3 people who have not passed the qualifying examination after 4 attempts. So you can pass the examination, you're just going to have to focus and work hard. And you may not pass it your first time, particularly if you're a new student, an international student. You don't really quite understand what you're up against on that first attempt. But I encourage you to go ahead and sign up and take the exam your first semester, even if you feel that you're not prepared, because you will get a better idea to know what you need to do in the spring semester in order to pass it. So if you don't go to the exam, then it's not going to help you at all, and you're just going to lose one of your opportunities. So even if you're not prepared, I would recommend going that first semester. Okay, other questions? Okay, dissertation document, pretty much the same as the thesis document, and it's typically much longer. Yes?
So going back to the research hours,
Yes.
this may just depend on the professor, but if we have an assistantship and we're enrolled in research hours, what is the expectation of, there's usually like an overlap, do we work our 20 hours a week and then 3 to 6 hours on top?
So there's a good bit of variation from semester to semester as to what your research activity is going to be. And it's going to have very little correlation to the actual number of hours that you sign up for. In most semesters, well, like I said, your typical course load is 13 hours, and that's what you should be targeting. But to get to that, well, our courses are all 3 hours each. And so you're thinking, well, that's 4 courses, and then I got 1 hour I got to get from somewhere else. Well, that 1 hour course would come from the research hours. But 4 courses is an extremely heavy load for a graduate student. It's very rare that you ever see anybody take 4 courses. Most of the time, students are taking 3 courses or less. Maybe 3 courses when they're starting out and they're not doing a whole lot of research, but then in later semesters, they're only taking maybe 2, maybe even 1. And then if a PhD student gets towards the end of the coursework, they may only take 1 course or no courses. And then once they finish the coursework, they're taking none at all. And so what they do is they use the research hours to pad their schedule up to 13 credit hours as needed. So if they take 3 courses, that's going to be 9 hours. They're going to add 4 hours of research on. And so almost every semester, the students are going to be taking some research hours. Now, whether they're actually doing much research during that time or what they're actually doing in research really has no bearing on the actual number of hours that they're signing up for. It's really more of a padding issue. Now, sure, when they're done with courses and they're taking nothing but 13 credit hours of research, they're probably going to be doing nothing but research, unless they're a TA and they're going to be handling labs or something for their courses. But it really fluctuates. You may only have 1 hour of research, but there might be some research deadline that has to be hit that semester, and your major professor is going to have you really work hard on it. So you need to know what's coming up with the research, and you need to tailor your course schedule according to what kind of deliverables you might have in a given semester. But you have to work that out with your major professor. Yeah. Other questions? No. Okay, dissertation document, graduate committee. So graduate committee for the PhD is a little bit different than the master's. So you need to have, of course, a major professor, and you're going to have committee members. You're going to have 3 committee members. Now, if you have a minor, you're going to have an additional person that's going to be your minor professor. So you will have a total of 4 people on your committee, a major professor and 3 committee members, if you do not have a minor. But if you do have a minor, you're going to have a total of 5 people on your committee. So this is different than in a master's degree. In a master's degree, you have 3 people on your committee, regardless of whether or not you have a minor. It's always 3 people, and the minor is one of your committee members. But in a minor situation for a PhD student, that's going to require an additional person on your committee. So that's something to keep in mind. The major professor, of course, has to be from ECE, but the other people can come from other departments. The minor professor, of course, must come from the minor department if there is one. Same prerequisite courses and transfer credit. A PhD student can transfer up to half of the coursework for their degree from another institution, but not from outside of the U.S. Okay. And then this is what the sequential pipeline looks like for completing your degree as a PhD student. Committee request forms and graduate program of study form, of course, in the first semester of enrollment, and then pass the qualifying examination within the first 2 years of full-time doctoral enrollment, or 4 attempts after completing that hours. And then that's pretty much it until you're about the time of completing your coursework, and then that's when you do your oral preliminary examination, also known as the proposal defense. And then that's pretty much it until you get into the semester of graduation, and that's when you do your dissertation defense. And so there's a good bit of paperwork and everything that goes on with a dissertation defense. But that's it in a nutshell. Any questions on the PhD program? Yes.
I'm a faculty, your faculty.
Yes.
One question, I would like to clarify with students. So in a committee, do we need one external examiner?
No, we do not do external examiners. And
So that three committee could be the department.
yeah, they
and
could all be
some-
from ECE.
Oh,
That's correct. Other questions? Okay, well that, the next section is distance ed, which we won't go over. So that pretty much wraps up what I want to talk about in terms of the handbook. We'll break now and have lunch. We have pizza and drinks in the back here. If you need to go to a restroom, you'll find it down the hall. So we'll spend about maybe a half an hour or so eating some pizza and just kind of relaxing a bit, and then we'll get started back up with some presentations from the emphasis areas as well as from Mr. Ellis about facilities and building access. So go ahead and help yourself to those pieces back there. Okay, so we have Mrs. Moorhead with us, who will be talking about IEEE. No.
Okay. All right. So we have some students that have been associated with Mississippi State before, and we have some new students. So I want to welcome everybody because you're all new graduate students. So welcome to Mississippi State, and maybe you're familiar with IEEE. I figure out how this works. There we go. So IEEE is the largest professional society in the world, and it encompasses all areas dealing with electrical and computer engineering. So whatever area you're interested in, whether it's power or remote sensing, biomedical, whatever areas that interest you, IEEE has a society that's associated with it. Okay, Jim, there we go. This is going to be a problem. No, we went the wrong way.
There you go, yes.
Okay, so obviously IEEE student branch membership is growing. We're growing locally, we're growing as a region, all different areas. And so we want to keep that up because we want you to keep your contacts. We want you to make contacts, and we want you to have those contacts forever. Come on. Okay. So where do you begin? You begin with the student membership. Okay, the student membership is really the beginning of your professional education. Hopefully it will let me go So, if we start here, you're a student right now, right? But you know that very soon you'll be moving into the professional realm, although as a student you're still a professional. But as an IEEE member, you'll start out as a student member, which is really nice because the prices are so much cheaper for students than they are for the professional members. So student and then member, and then senior member, and then fellow would be the path that you would take as you moved up. And so, as we continue up and we talk about opportunities for students, right? Certainly IEEE provides you the basis to increase your technical knowledge, things that you can do, things that you can get involved with. We have local competitions, we have international competitions that we locally are involved with. Maybe you're familiar with Extreme. It's a 24-hour programming competition worldwide. It's really fun to do. It usually occurs in October, and so we have teams that spend all night and program all day and all night and just have a good time, a good way to get to meet people. But if that's not your interest, you can certainly do other things. We have robotics competitions. We usually leave that for the undergraduates, but you do have the opportunity to be in the open field if you are interested in building your own robot to be in a competition. As graduate students, you're going to find that you're going to want to be going to conferences, and so being a member of IEEE, you'll have the opportunity to student tracks. You can present in student tracks. You can present in professional tracks. Volunteer development. I've sent students that spent the entire summer in Washington, D.C., fully paid opportunities to be involved with Student Congress. Okay. Sorry. Okay. So that technical advancement, community oriented. We have opportunities for you to be involved in the community. We have local activities where you can meet new people. We have volunteer things like Engineers Without Borders. We have an Engineers Without Borders group here. We have, we've done the pre-university activities. I know as students, we're usually really busy, so I try not to have them do too many things. But certainly awards and recognitions. We've had a lot of students who have gotten really nice awards from IEEE. The Power and Energy Systems group offers really nice. Several students that are actually sitting in this room have gotten really, really nice, you know, 5,000 and so forth awards, which is nice to help pay for things that you have. So the awards are nice. Career programs, always job fairs. There's a really nice one up in Memphis that we've taken students to. Obviously, we have a very good career center here, so we don't need to do that, but IEEE does provide you with opportunities. We have several events in Huntsville this semester that are going on that we'll be involved with, lots of soft skills seminars. Most of this is online. IEEE has a huge online appearance. Things that you could do. Obviously, the Potentials magazines, lots of ebooks. Standards is a nice group. I've been involved with Standards to be involved with IEEE societies. There are 52 different societies, and that's always growing for different areas. And so IEEE TV was another area. We could just look at that. Maybe we're online. I don't know. Are we online, Jim?
We are.
Okay, maybe it'll take us there. Maybe it won't. Oh. Maybe we're there? Oh, we are. Okay. All right, and so IEEE TV provides you with all sorts of series. There's a lot of Ada Kappa New things here. I don't know if we can see things, but you know, there's a lot of, at least this morning, all of these were Ada Kappa New. Well, anyway, obviously they're going into one. I don't want to go into one, but lots of series that you can see, so you can go and check that out. And then channels, lots of channels that you can go to, you know, if you want to learn new things and so forth. But you could spend all day going through here. Education, again, lots and lots of things to learn on. I was trying to teach a class on fiber optics. I thought, oh, I better brush up on fiber optics. And so I was able to go in here and learn quite a few things about fiber optics and actually teach the class, which was nice. And so then to go back, let's just go back here. And so IEEE TV, available to you as a member. Some of the things that you could do as benefits, as I mentioned, IEEE TV, there are job sites. You can see there's all sorts of things that you can get involved with. Some of the things that we have here, we have the student awards. We have Ada Kappa New, and I wanted to talk a little bit about Ada Kappa New. We also have an IEEE Women in Engineering section, and so those might be two areas that you might be interested in. Let's see if we can go to the next page. A few more benefits. The Google Apps is really nice because then you can just run it locally. Right? Sorry. Okay. As far as the local student branch, like I said, we have several different activities. We have the student branch. We have the IEEE Ada Kappa Nu Honor Society. Ada Kappa Nu is the Honor Society. We have the Women in Engineering, and we also have Computer Society. So we have several local things, and I think they're trying to get a Power and Energy Systems group going as well. And so different areas where students and professionals would come to meetings and get to meet each other. So just the things. Couple links that we could link to. I'm not going to go there because we just saw that it wasn't as easy as I had hoped to get to. But we will be having technical presentations. We try to have technical presentations once a month. And actually, this semester, actually this year probably, because we have so many new faculty, I'm really going to get all of the new faculty to come and talk. And those will be our IEEE seminar series, which is what we have with IEEE. So the IEEE student branch will be having monthly seminars, maybe bi-monthly seminars, so that we can get all of the new faculty in so that they can talk about their research, because that's really important for the new faculty to have the opportunity to do that. The Ada Kappa New Leadership Conference is nice. I've sent students to that. It's usually at a different university. We've had it at Notre Dame, we've had it at University of Michigan. The graduate students are usually the ones that are really interested in going, so I've typically sent 3 or 4 students to the Ada Kappa New Leadership Conference. As I already talked about the extreme programming competition, you'll be hearing more about that in September. It's actually the second weekend in October. We'll be talking more about that. So things that you can do through the student branch, this is really up to the officers of the local student branch. And so I let the local student branch run what they want to do. In the past, some of the things that they wanted to do, they wanted to work on presentation skills. And so we had several seminars with presentation skills. You know, they wanted to work on management skills or budget skills. So again, this is really up to the local student branch and your officers. And if you want to be an officer, we're always looking for officers. So please let me know if you're interested in being involved in the leadership of the IEEE student branch. We talked about IEEE TV. Again, it's a great avenue for learning and for keeping up with some of the things that are going on. Certainly an impeccable character. I don't know about it, unimpeachable anymore, because who knows what's going on there, but possess an unimpeachable character. And you know, those that are in Ada Kappa New are those that are at the very top of their class. As a graduate student, you have maintained a very good GPA. Right? And so being in graduate school, you've obviously met all of these requirements. And so you will be getting a letter inviting you to be a member of Ada Kappa Nu, and we certainly encourage you to do that. And so with Ada Kappa Nu, as I mentioned, it's by invitation only. And so, but as a graduate student, you've already met the GPA requirements for that. So we'll be invited for that. And IEEE now, I have a lot of students that tell me they like to get on in the social media aspects of IEEE and converse late at night with a lot of people, so they do that. For graduate students, you obviously can be a member of any of the local ones. You can be a member of the International Society, and that is how you become a member of the local society, and so we hope that you'll get involved. Okay. When you do join IEEE, things that you will have to do, we ask that you become a member of the Mississippi State University branch. Because if you're already a member of the IEEE from another university, then you won't be able to get access, or you won't hear about the events that are going on here. So just make sure that when you join it as Mississippi State University as your institution. And then also make sure that you use your local address, because they'll want to contact you with your local email and your local address if you're receiving things through mail. So, all right, and we sort of already went to the IEEE website. Maybe I didn't point it out. Let me just jump there. So, you know, all you have to do is basically click on Join IEEE, and it will step through. And like I said, it's very inexpensive. It's usually less than $30, $35, or $40 to join. And then as you join each of the societies, a couple dollars, or some of them are free to join those. Much different than if you join as a professional. So make sure you join as a student while you still have the opportunity to do that. But we'll be in contact with you, and that was really just a quick overview of IEEE. Do you have any questions, or so? No? All right, good. Well, I wish you the very best in your studies, and I look forward to seeing you around the department. Yes?
Actually, I was recently elevated to senior membership,
Wonderful.
and I received, I guess, 3-4 discounted memberships. So if anyone interested, they can reach me, and I can share it with you.
Yeah, really great, thank you. And so, you know, that's a great way to build up your camaraderie, get to know the professors. So by all means, yeah, thank you. Okay, thank you, Dr. Teller.
Great.
All right, at this point, we're going to have our emphasis areas talk. We also have Mr. Ellis coming in. So Brian, you've got your presentation ready. So go ahead and plug it in there, and I'll have Dr. Jones go first. I can do it with touch, I think. Oh, no, I don't. Put the X in. Okay. Okay, there we go. There. This one right here, got her. Okay, there you go.
All right. Well, again, thanks for coming to the orientation. Excited to have you all here, Dr. Jones. And wanted to talk to you a little bit about our emphasis area. So we're the digital systems and microelectronics emphasis area. A number of faculty are in that group. Of course, there's myself, Dr. Mohammad Iraq, Dr. Koshka, Dr. Luo, right there. I'm going to say hi briefly. And Dr. Luo, who's a different one, who's not with us today. So, briefly, we go through a number of areas. Again, we're really focused on making exciting things, bringing intelligent things to life, and giving you the skills, the opportunity, and the knowledge to power our world, to build the world for humanity. If you look at what's happening right now, so many of the problems that our world faces, so many problems that our society faces, have solutions that are amenable to analysis in electrical engineering, from prosthetics to global warming to social networking to so many other places. It's a great place to be. We want you to be involved in shaping the world for all of us. So there are a number of classes. There's kind of a smorgasbord. I know that Dr. Fowler, I believe, will email these slides around. What we would want to, one way for us to get to know you and know more about your skills and interests and capabilities, to take a course with us, and so we can more assess where you're going and what sort of, what emphasis would be most appropriate for you. So I'm not going to spend too much time on this. I do want to talk briefly about each faculty member and their emphasis. So I'm really passionate about something I call literate programming. It's the idea that a program is not simply a series of instructions to a computer. That's what do I do, but why? Why did you do it that way? Can we treat a program more like a Microsoft Word document? Put in flowcharts, diagrams, hyperlinks, a Stack Overflow, explanations, ideas, because a program is a form of communication from one person to another about how they did it and why they did it. So can we use this idea that a program is a document? It's a why, not just a what, to teach students to do a better job of programming, to enable professionals to do a better job at the things that they do. So I'm really interested in literate programming, writing the learning program, and I also work with Dr. Mohammad Iraq in that area. If you want more information, I am looking for students and would love a chance to work with you. Dr. Koshka works in the optical characterization lab, where they do a lot of really interesting things. He looks at fabricating nanowires, so he's really interested again in making these very small scale structures to enable some novel applications. All right, here we go. And then again, here's some electron microscope pictures of the different structures that he's able to produce in the lab. Let's see if I can find the slide advance here. Sorry, I'm not. Okay, that's what I do. There we go. So here's a nanowire field test transistors, a biosensor. And we go a substrate, put the nanowire on it, then add some bond wire, nickel bond wires, and then actually grow those structures on top of new things. So some really exciting things, again, at the microscopic scale that changes our society on the macroscopic scale. And here you can see the sensor is actually adapting, connecting to a specific target molecule and able to identify and recognize that. So, you want to briefly talk about your research area? You'll speak more intelligently than I can.
Thank you. This is Chao Ming Luo, actually from Wayne University transfer to the Mississippi. I'm really exciting like you joined the Mississippi State University. That's my research. You can see that some of that, because I have some industrial background, so some a little bit more cross-disciplinary research like okay, that's okay, I go back. Particularly, most likely my research is
Swipe should take you back. There's swipe the other directions. There you go.
yeah, most likely robotics, autonomous robotics, we applied machine learning technology of computational intelligence technology, optimization technology onto the robotics, embedding the system or control system. That's my main research work, hands-on research work. And then we have a focus on the real world application, not only theoretical stuff. For instance, we develop a new algorithm applied onto the real world application. My research is most likely in the research like navigation, localization, image processing for the robotics. That's my research. Thank you.
Thank you. So again, Dr. Liu, if you want to know more about his area, which is, as you said, encompasses both robotic systems and some exciting applications in the scene. Dr. Liu does a number of interesting things with cyber physical systems and cybersecurity. He's got a couple different foci. One is wireless information, ways to move data from very small embedded sensors all the way up, aggregating, collecting, analyzing, thinking about interpreting that data. And then in another way, you do a lot of really interesting things in acoustics. It turns out that if you look at the way mankind uses the world around them, they tend to emit a lot of frequencies that are disturbing to marine animals. So are there ways that we can change the kind of signals we send so we don't disrupt the natural environment, but still maintain the ability to perform sensing, mapping, navigation in an underwater environment? It's a really interesting research area. It's something I think is very novel. So that's his area. So we have a number of interesting areas. We'd love to get a chance to work with you, and please contact us if you'd like more information.
Great, thanks. So next we'll have Mr. Ellis, who will be talking to us about facilities access, computer networks, that kind of stuff.
Yeah. All right, how's everybody doing today? Sure y'all getting a lot of good information, finding out some new professors to talk to, think about. What we'll go with y'all today is computing infrastructure, what we have here in the building for y'all, between anything between servers, email, how to get help, those kind of things. I guess the number one thing I always like to start out with everybody is explaining the MSU and the ECE accounts that we have. They're not the same. MSU has their own. It's your net ID and whatever password you set up. The ECE generally uses your net ID for your username, but it's a separate password, or you can make it the same. But it's used just for accessing machines here. ECE, it won't get you in the bank. It won't get you onto your building map. It won't do any of that stuff for you. But it will allow you into the lab machines in 131. It really is machines here in the building. It's your granted access to use. Use that username and password. It gets you onto the intranet, which basically is going to be everything I'm going to tell you today. But so you can go there, and what I talk about today, you'll be able to find. Yes, next thing we'll hit is printing. It's grads, so y'all get a couple hundred pages a month, 200 pages a month It's not like a phone plan in the old days, no rollovers, so $200 you get. So if you use 50, you only get 50 more to fill your month back up. And undergrads have always gotten 100, so you only get twice as much. Free printing, as far as I know, we're about the only place on campus that offers that, so it's a little perk. Email policies. Always, this is more for the professors and y'all's grades than anything else, but always use your NetID at mstate.edu. Check it. It's your official email here. That's what your professors will all email to. They won't email to your Gmail account. If they do it, don't count. So basically, they have to email to their official. So that's what they're going to send to, and that's what you're going to get your communications to this university with. So make sure you always check it. Believe it or not, we've had it in the past where it's not the case. So it's the reason we stress it. Help desk tickets. Being grad students, you may or may not be assigned a cubicle. So with the cubicle come computers, maybe door access, trying to get your software working, your math lab, cadence, whatever it may be that you're using, depending on the professor. If you need help with any of that kind of stuff, what you will do is send a ticket, a request to help at ECE.mstate.edu. It'll be on the intranet, it'll be on the website, it's kind of around a bunch of places. So you'll be able to find us no matter what. If you're here in the building, room 131, that's our IT department. So everybody can come down and, we'll help you out there. A lot of times, if it's a more complicated, they will tell you you're going to send a ticket in because you may or may not have time when you walk in the door or immediately. So those things happen. So just mainly send in tickets. That way we keep up. There's 4 guys down there generally at all times, besides me, and that's what they do. They make sure software is working. Paper jam, stuff like that. Intranet, kind of went over it a little bit ago. If you go to the main Mississippi State or ECE homepage, top right, you'll see ECE intranet up there. Or you can just type in intranet.ece.mstate.edu. That'll get you there. There you'll figure out several things. There'll be an important one, printing. So if you have a personal laptop, it'll show you how to set your personal laptop up to print. VPN, you'll need that for the printing. Access to file shares, that, depending on the professor, may not have something for you to do there in file share. And just other various topics that may be of interest to you there. There's a few software downloads there that they may get you to use. Like I said, all depending on the professor if they ask you. So go to the intranet, take a look at it, see what's there. All right, next, door access, lab access, stuff like that. To get lab access, you may have to remind your professor. But I won't give you lab access or door access or anything like that till I have an email from your major professor saying, hey, grant so-and-so access to this. That's to cover me and them, you, and everybody. It's a real simple thing. Just have them make sure they send me an email before you come down there saying I can't get in. Past that, that's the biggies. Do I have any questions? Any questions for me? Printing, email, networking, personal computers.
I'll just emphasize your official university email address, your NetID at mstate.edu is very, very important. If you have another email address, you can use it, but you need to get the email that goes to your official university email address forwarded to you. Because me in particular, I will not send your email to any other address. I will send it to your NetID at mstate.edu. And you do not want to miss emails from me. Trust me.
That's true. Well, if y'all need me, or any of my guys, we're down. It's room 135 here in the building. through the wood double doors all the way to the end. Y'all come down and see us anytime.
Great, thanks.
Take care.
Okay, next we have Dr. Fu with Power Area.
Okay, so good afternoon, everyone. Welcome to MSU. Welcome to ECE department. My name is Yung Fu, associate professor in Power Group. So today I want to take this opportunity to talk something about our power system, high voltage, and control area. So also to give you the very short presentation about our teaching and research activities in our group. So the first thing I want to talk about who we are. So we have the 5 faculty who work in the power and energy area. So we have Dr. Foley, his area is mainly focused on the controls area and application. So that's me, so Yung Fu focus on the power system study. So especially take some study about the transmission, distribution, microgrid study, something like that. Dr. Karimi, Master Karimi, so he work on the power electronics and control. Also, the Dr. Shaw is also working power electronics and control. So Dr. Yoni Cruz, he worked for the high voltage engineering. So we have a lot of teaching and research activities in the high voltage lab. Later I can tell you more about that facility. So we have different expertise. We focus on the different research area. We do something about the electrical power system, transmission, distribution, power electronics. In order to integrate any renewable energy, so that we need a lot of technology for the AC, DC, DC, AC interface. So how to control this interval, the interface, how to control this interval, so the frequency, also the quality of your power supply. So a lot of study here. Also, we do the optimization modeling, high voltage study, and also we have some study for the transportable electrical system, and the electrical vehicle car, and also the shipboard power system. So our research from the different phase, so we get the support from our federal agency recently. So we have the NSF for funding, we have the DOE support. We also have some collaboration with the national lab, Oak Ridge National Lab. We have several projects with that. Also, we have a very good relationship with the industry and the utility, something like the GE company, TVA, energy. Also, we have some projects with the PG&E. So this is many the research opportunities for us. So we can work together on that. Some courses, graduate level courses we are offering. First thing about the split level, as I think you know what's the meaning of the split. That means both undergraduate and graduate can select this course. For example, we offer transmission system, distribution system, the power system relay control, introduction power electronic, insulation, fundamentals of the high voltage engineering, feedback control 1 and 2. So if you want to register the split level course, you can make sure that you register at the 6,000 level. That is for the graduate student, for both master and PhD students. Also, we offer 8,000 level course for graduate students. So for example, we have regular course, power system stability and control for the distributed energy resource, something like that, distributed renewable or non-renewable generators or the energy storage. We have the high voltage engineering course, power system operation and control. Basically, we talk about how to optimize your power flow, how to get the efficient and the high quality power supply to end user. So we also talk about nonlinear control, random processing, magnetic control, optimal control study. Sometimes our professor also talk some interesting topic in the power and energy area. For example, we pick up several special topics here. We have high voltage measurement techniques. We talk about the smart grid, renewable energy integration. Also, we talk about the power system economics and deregulation. Basically, we focus on some discussion about the electricity market. So the how to price, right? So the how to price and how to run the market. So how to get benefit from this operation. Okay. So that's the courses we're offering. So I want to emphasize these 4 courses we're offering this semester. So I'm offering the power transmission system. Dr. Yuni Cruz, they will teach the fundamental high voltage engineering. Dr. Brady will offer 2 courses, one for spirit level, 6,000 level, one for 8,000 level, one for feedback control and optimal control. Okay, please take a look at this opportunity and think about these courses. You will learn more about the power and energy system in this area. One more thing about the somewhere. Oh, maybe. Okay. Okay. So one more thing I want to talk about is the 8,000 level, 8,000 course and 9,000 course. I don't know how many master students in this room. Can you please raise your hand? Okay, I think the rest part is for the PhD student. Okay, please make sure that maybe you want to get some opportunity to work with your professor, faculty advisor, talk with them, and to work on some interesting work. And you may want to register some credit for research credit, right? So before you do that, please make sure you get a permission, you talk well with your faculty advisor, identify the project and make a good plan. So especially I want to mention, okay, for master students, please register for the 8,000 course. So for PhD, please use the 9,000. That's the code for your study in order to get the research credit from that. Okay, so some possible research activity I want to put here to get your attention. For example, let's start from power system study. For the power system, we do some optimization issue, for example, planning, maintenance, scheduling. So also we talk about the electricity market, economic issue, right? How to get benefit, how to maximize your benefit and minimize your operation cost. So all this is interesting stuff we will cover here. So we also talk about the stability issue, dynamic behavior of the power system. We have some study or research effort on the wide area monitoring and control of the power system. I didn't know that we have some advanced monitoring system, single phaser. So we can use this new technology to cover the big area of power system and conduct some study, monitoring and control, emergency activity. So we also study the integration of the renewable energy into the power grid, not only for the microgrid, the small system, we also conduct a great scale integration for the large scale system, for national grid, and what kind of impact we will get from renewable energy. So a lot of training field from here. I didn't know the renewable energy is accident, right? So a lot of that issue we need to cover. Smart grid, that's a hot topic in recent years. So a lot of people talk about the smart grid, what they can do. Some people talk about control, some people talk about the monitoring, some people talk about the other, like the cyber physical system, right? So we also have the different studies. So for the smart grid, for me, my group, I do 2 things. One is the cyber physical simulation and coordination. Second one, I will focus on the microgrid system, especially from the network and microgrid. Not only one, the multiple microgrid have to work together. So you may want to use the centralized control, you may want to use the decentralized control for different options that we can do some study over there. Also, we have the big group for the many efforts for the power electronics. So we talk about the multiple functional power electronic power converter system. Dr. Karimi also do something for the phase lock loop and the nonlinear filtering technique, and also focus on the optimal robust nonlinear control for the power electronic system, also the design, high reliability, high efficiency, high-speed electrical machine and driver system in this area, especially for the transportation application. So we have very wonderful group for the high voltage engineering. So here we, Dr. Yun Group, do some study and teaching and research activity for the lighting protection, and also do some study for the electrical fabrication of the machine, welding insulation stuff, aging of the insulator. So the many work, the high voltage lab will be working on that. Also, we are not only working in the individual area, focus on our individual faculties, the interesting area. We also work together on several collaborative projects, something like the electrical vehicle car. The several professors work together on the modeling and simulation of the hybrid vehicle, control and the energy, the battery management, charging, recharging, how to control that. Electrical vehicle car, we get a support from the Navy. So we design the basic the power supply, the architecture. We have different options. We have the medium DC architecture to build this distribution system. For the E-shape, I mean electric shape or the power system, that is like the isolated microgrid, if you want to say that. So in this system, we have the medium voltage DC power supply. We also can use the medium AC, voltage AC system power supply. So that we compare these two systems and get what's the benefit, what's the advantage, what are the disadvantage. Many studies we work on. We also, for this project, we work with several universities. We have the ECE consortium, so work with the Florida State University and Purdue University and other several universities we work together on this big project. Okay, so I want to take this opportunity to talk something on our facility and equipment, what we have. Maybe that will benefit your study and the research in the future. Okay, so first one I want to talk about, we have the RTDS lab. How many students know RTDS? Okay, so RTDS, the full name is real-time digital simulator here. So that means, okay, I think the most of the students have experience using the MATLAB, right? You use the simulate to build a small power system, a circuit system, and a simulate, right? So sometimes even for the 10-second simulation, you need how long? Several minutes, maybe sometimes over the 1 hour to get the simulation result. That's very time-consuming work. We have RTDS. We use a new technology. We use the parallel computing here. That means that you build your system, you simulate your system. Basically, you can get the real-time result. You can get an analog result, like the real power, reactive power, frequency, voltage. That's all information we're monitoring, right? In our system. You can also get the digital signal. I mean, the status of the switch on or off. All this information. So we get all this information. We can get output. This interface from RTDS. Middle part is RTDS. We have two racks over there. We connect this information with our device, hardware device. We have the relay one side. We have the monitoring signal filter other side. That means that we have this facility or equipment to conduct the hardware in loop this simulation. So that gives us a lot of opportunity to conduct some high quality of the research. So next one, we also have the renewable integration. So actually the very close to us, just go to the roof of this building. We put the 24 solar panels on that. So the total megawatt is the kilowatt is around 6 kilowatts power supply from solar. We have very good storage from solar power. So that we also have a wind turbine there. We have two 1.5 kilowatt for each one. We have Honeywell wind turbine. So we put all this system together. You can find this indoor equipment, inverter. We have Sunboy, we have the OpTech. So all this inverter to get the power from the DC power from the one from we have all system, we start this system 5 years ago. We are monitoring data, we all collect all this data. Students can use this data for forecasting. Students can also come here to take a look at all systems to get the first-hand experience on this renewable energy, I mean the small scale at least, so that get some idea how to connect, how to design this system. For example, if you want to customize or build pick up your equipment, right, for your own house. So how many panels you need, how to connect them together in series, in parallel, right? How to customize your voltage and current and also pick up the proper inverter, so you get a lot of the idea from here. So I think that is also opportunity for you to take a look at that. So for power electronics, so that we have a very wonderful lab for the power electronic converter and control. For here on this picture, we have we call the PEBB. What's the name of PEBB? The full name is Power Electronic Building Block. That means we have microfunctional inverter here, the phase A, phase B, phase C. So you can customize all this PEBB inverter. So to implement your idea, implement your control algorithm, so that you can act and with the load here, so find out what is the quality of your power, right? How to control the harmonic study, right? So to conduct the harmonic study, also you can conduct it using connect two inverters in parallel, so what the impact, how to control that. Okay, so that's the one more thing I want to talk. This is also the power electronic and energy system operated by the Professor Choi. So he worked on this electrical vehicle car application. So dividing the control algorithm to control the motor charging, discharging, and that's in his lab. He also has a wonderful experience on the how to design the motor, electrical machine, how to conduct the thermal analysis. Also very interested in the research topic related to the wireless charging, right? Electrical vehicle charge, many places we can use this technology. For example, UAV. I do remember last year, one senior design talked about this opportunity to design the wireless charging for UAV project. Anyway, so the many applications opportunity here, so please find the opportunity to talk with our professor. Last one, also the wonderful lab we have. You may or may not know the high voltage lab is the largest university operating lab in US. So that we have wonderful facility to generate, we have the high voltage AC, DC generators here. We conduct many the testing, and also that we teach our course. So sometimes we have experimented in this lab, so the student can get experience and learn something about the high voltage related study. So the insulation coordination. Also, we work with many utilities, so to help them to test their equipment. For example, cable, switch, right, breaker. So they bring here in our lab and we conduct this research. So that we also help them to do some standard evaluation surveys, provide that to make sure that they follow the code, national and international standard. So the many opportunity and ideas comes from the high voltage lab. So I think that that's the wonderful lab we have. Okay, let's go to the last one. That's the aim. I will list this information for your reference. We have 5 faculty here, professors who work in the different area. Again, so the Dr. Cho, he worked on for the power electronics and energy system. Fowler, control theory and application. For me, power system studies. Dr. Karimi, power electronics and control, renewable energy integration. Dr. Yoni includes the high voltage engineering. So please find the opportunity to talk with our professors about your background, your interest, and find some the opportunity to work together to finish your master and PhD program. So okay family, I hope all this information are helpful. So any questions about the power and energy system you want to know more right now? Otherwise, thanks a lot. So by the way, I think that all this information will be online, right? So you can you can read more later anyway. So if you have any questions, let me know.
Okay, fine. Okay, so I'm going to be talking about the signal processing and communications emphasis group. And as you see, we have quite a few faculty in our list here. However, not everybody is that involved in research. You see, our department head, Dr. Yunin, is on our list, but as the department head, he does not typically advise any graduate students. Dr. Moorhead is over at GRI. He's the director of the Geosciences Research Institute, and he does not advise many graduate students either. And then me, I'm on here as the graduate program director, and my advice is somewhat reduced as well. But we have plenty of other people advising students, including a number of new to fairly new faculty. Of course, this doesn't work. That's different point to go. Okay, so we have courses on the books that deal with a vast array of topics. Your classical digital signal processing, image processing courses, through spectral analysis, remote sensing, random signals and systems, electromagnetics, radar signal processing, neural networks, and then communications. And then a bunch of courses over in the math department we find are also useful to a lot of our students. So these are the types of courses that you would be taking as a signal processing communications student. Specifically for fall 2018, we have the following 4 courses being offered at the graduate level. The first 3, of course, are the split level courses, and then neural networks as an 8,000 level course. Okay, so our faculty, Dr. Moorhead, as I said, is the director of the Geosciences Research Institute. He's also the director of the Northern Gulf Institute, and he's housed over in the research department. He does a good bit of research in unmanned aerial systems, vehicles, and such, specifically for environmental analysis. Previously, his research focused on visualization and image processing. Dr. Yunin is our department head. His traditional research areas are signal and image analysis, estimation detection, and pattern recognition. And here I am. My research area is in generally the communication and processing of images and video, specifically with a focus on geoscience data, remote sensing type of data. I teach a course on wavelets, and I also teach a course on information theory. And so these are the 3 courses at the graduate level that I rotate between, but this semester I'm teaching at the undergraduate level. Dr. Du is a professor who focuses in the remote sensing area, particularly hyperspectral remote sensing. She also very frequently teaches our digital image processing course, as well as pattern recognition, neural networks, and random signals and systems. And then Dr. Ball also has done some work in the remote sensing area, specifically in the radar area. Radar signal processing is one of his classes, as well as there's a class on introduction to radar. He's also taught our digital signal processing course and a statistical signal processing course. So here you see some ugly pictures of the things that he has been Bo is our one professor in the electromagnetics area. And so some of the classes that he has taught at the graduate level include antennas, microwave, computational electromagnetics, and electromagnetic compatibility. So he's had some work over in the high voltage lab as well with these research focuses. Okay, Dr. Karoon has also worked in the remote sensing area. A bunch of us have worked in remote sensing. His focus is on a microwave and millimeter wave aspect of remote sensing. But he also works in the electromagnetics area and other forms of sensing. So what he has taught in the past is the RF and microwave engineering course. Dr. Tang generally works in the machine learning and big data areas. So is concerned about data mining, statistical signal processing, smart grids, and those things. He recently introduced a course on cloud computing and had a great deal of popularity. Dr. Gerbuz, did I say that right?
Yeah, thank you.
Very good. Okay, he's one of our new faculty. Would you like to tell people about yourself since you are here?
Okay. Hello everyone. So my name is Ali, Ali Gürbüz. My general area is actually signal and image processing, but I'm mostly specialized on radar and array signal processing and machine learning applications on that. I also working on compressive sensing, which is kind of a sparse signal processing approach, which reduces number of measurements and kind of taking in either sensor numbers or the memory numbers, so it's kind of reducing the load. These are not the courses that I'm teaching, but kind of courses that falls into my research areas. I will be teaching electromagnetics as an undergraduate this semester, but next semester I'm possibly planning to teach one of these courses, also open a new course in detection estimation or array signal processing areas. I might add, I'm also doing radar, but kind of additionally doing the imaging part of these applications like radar imaging, synthetic aperture radar imaging, or ground penetrating radar, something like imaging underground or through the wall kind of applications as well. So if you're interested, I am in 335, would like to chat with you and more, kind of these areas.
Great. Okay, we also have Tom who is a new faculty member. He is not, oh, there you are, over there. Would you like to talk about yourself?
So everyone, my name is Shikman. I'm a new faculty member here. And in my recent I was working on wireless communication and networking in the past about 5 years. But I'm still continuing working on that. And right now our focus is how to develop a new transmission technology for 5G or even 6G cellular network. And then another topic for this area also remote communication. How can we use very small energies to transmit a very high data rate? And also recently I was working on a UAV on unmanned area vehicle communication network. This is also a new area I'm still working on. And also I'm also working on several physical systems, especially for wireless communication systems. And also machine learning. How can we apply machine learning to communication and wireless network? And the main focus is how can we apply machine learning technique to learn how to allocate resources between users and different network. Yes.
Okay, and then Dr. Yu Luo, we've already seen him as part of the computing group. Sort of straddles our two groups because he has a great deal of interest in wireless communication networks as well as cybersecurity. He'd probably choose one of the two groups to go into, but I put a slide up here because of the wireless group. But I won't talk any more about it because Brian did a pretty good job about
describe his work. And then we have both.
Hi, my name is Luke. I work also in wireless communications, and mostly in 4G, LTE, and 5G technology systems. Related to that, I built test beds. I come from Virginia Tech, where I did my research, and just joined MSU, and I'm glad to be here as associate professor. So what I did before, I built test beds for LTE research. So we use software-defined radios to be able to customize our experiments and even the waveform itself, right? The protocol itself. So we did that and did some virus security research. We looked at what happens if you hit the control channels with a jamming signal, right? Or you try to spoof the signal. You've probably heard of IMSI catchers, like fake base stations that try to get your identity through LTE. So those are all unresolved problems, and they need to be addressed. And okay, let's say 4G is old. You need to work on 5G now, and it's still insecure. You can do a lot of good research to make it more secure, more reliable for public safety, etc., DoD operations, and so forth. I also work on wireless network virtualization, which helps you to share the resources, to share the network among different providers, and also share the air frequencies, the spectrum, more effectively. A lot of research is ongoing now for DoD, who has a lot of spectrum, to give it away when it's not in use to commercial service providers. So that's a big research topic, and it's applied, right? Because FCC already allocated a lot of bands for sharing. Also, one interesting project that currently has an NSF grant is on RF nonlinearity. So you probably heard that if you have a desired signal and you have strong other signals close to yours, then all those signals enter your RF processing chain due to analog receiver front-end nonlinearity. Intermodulation products are caused, or can be caused, right? Especially those two interference are very strong. And then they cause an interference on top of your desired signal. We analyze this again with software radios, we build a model, and so forth. We have one more year of funding for that. And lately I started looking at vehicular communications, car to car. And there's this standard called DSRC, that's an extension of Wi-Fi. But cellular also has a system called cellular vehicular to everything. It's based on LTE again. So we built this NS3 simulator to be able to do some research on how to schedule the resources when the cars talk to each other without infrastructure involved. Okay? Well, I'm glad I had the chance to talk to you. Thank you.
All right, so to summarize, we have quite a few people in the signal processing and communications area, so it's a really good place to focus, a lot of opportunity, a lot of funded projects, provide support, excellent researchers, excellent teachers, and we have people also in the university leadership positions. Okay, so that wraps up everything that we need to talk to down here. What we're going to do now is we're going to move into doing registration. And so I'm going to meet with everybody upstairs. So what we're going to do is go upstairs to the ECE main office, and I'll get you settled in the conference room, and then I'll be bringing you into my office in pairs, because I only have 2 seats in my office, and I'll get you all released for registration so you can sign up for classes afterwards. And I'll talk to you about what courses you should be registering for and answer any questions that you have about registration. Okay, so let's plan on meeting upstairs in the ECE main office in about 10 minutes. Okay?